Hello and welcome to this new video. In this video, we will study some basic notations of the group theory, and then we will study socks shoes property. So we start with some basic notations of group theory. Okay, let G be a group. For example, an element G belongs to G, then usually the inverse of the element G is denoted by G inverse. And similarly, if n is a positive integer, then associativity allows us to use Gn to denote G star, G star, up to so on star G n times. Here binary operation is star. And as for our convenience, we can write it as G into G n times, and we assume that there is binary operation operating between these G's. Okay, another convention is G to raise power 0 is always identity for all G belongs to G in a group. This is a convention. And when we take negative value or negative power, for example, G to raise power minus 5, which is equal to actually G inverse to raise power 5, means binary operation between 5 times between G inverse. Okay. Unlike real numbers, in group in the group theory, the non integral powers are not allowed, means we cannot take G to raise power 1 by 2. So this is not allowed in group theory because this does not have any meaning. And for all m and n, m and n both are integers, m and n, and G is any element in G, small g is an element, we have Gm into Gn is equal to Gm plus n. And similarly, G trace power m and whole trace power n is actually Gm times Gm times Gm n times. and this is equal to G N M. In general, in a group, because group is not commutative in general, so A B to raise power n is not equal to A n B n in general. Okay, if the binary operation is positive, then of course, if we taking G plus G n times, instead of G to raise power n, we write it Ng. And also, uh, if the binary operation is positive plus addition, then A minus B is actually equal to A plus the inverse of B. Okay. And uh, we have a note or a remark. Although this property A, B, N is not equal to A and Bn in general, but we have a simple relation between the three elements A, B inverse, this is an element of G, another element A inverse, and B inverse. And that simple relation is called socks shoes property. And the statement of this property is, for a group elements A and B, we have AB inverse is equal to A B inverse, sorry, is equal to B inverse A inverse. And we have a simple proof. Since if AB is an element and we multiply this element with its inverse, we will get identity. AB is element because in group we have closure property and A and B are the elements of group, then their product is also the element of group G. So AB is an element and AB inverse is the inverse of that element. And the product of an element with this inverse is the identity element. So we consider AB into AB inverse. Okay, no, we consider AB into B inverse A inverse, and due to associativity we can take it as B inverse and A inverse, and because this element is identity, so we have A into E into A inverse, and this is equal to A inverse, which is equal to identity. Okay, we have two equations. First one is this, and the second one is this one. If we compare these two, because the right hand side of both equation is same, therefore left hand side is also the same, are equal. And since we know the cancellation law, so this element can be cancelled, and we have AB inverse is equal to B inverse A inverse. Okay, now I will explain that why this is called socks shoe rules. If we consider A is equal to socks and B is equal to shoes, and if we first we will wear the socks and then we will wear the shoes. But if we want to have the inverse process of this socks and shoes, then first we have to remove the shoes and then we can take off the socks. So the inverse of socks shoe rule or property is first we have to remove the shoes and then we have to remove the socks. So if you find this video helpful, then best way to support us is to like the video and to subscribe the channel. Goodbye.